Now let us talk about Selenium. What is Selenium and why we need it and when we need to use Selenium. In simple terms, Selenium is test automation framework for web application testing. Since most of the applications we develop are web-based applications, there is a high demand for automating the web applications, both internal to the company or external, like public-facing websites. This simple diagram can give you some idea. So Selenium is a framework to test web applications by definition. So if this is the browser and the application runs inside the browser, Selenium WebDriver provides certain APIs, application programming interface, like already developed code, how to interact with the browser and UI elements inside the browser. Basically, this is the username password, a text box which takes the username, and another text box which takes the password, a submit button and a clear button, right? And this is the URL. So the Selenium WebDriver out of the box has APIs which we can use to interact with the browser and also the elements inside the browser. It doesn't care what kind of application you're running. So if you are developing a travel portal, yes, you can use the APIs to open up the browser and interact with the elements on the browser which are relevant to your application. If you want to automate the process of sign in, you need to open up the browser and use the APIs to enter the value to the username field, value into the password field, and click on the submit button using the program. So which we will be seeing more in detail as we go into the coding part. To give you a high-level idea, Selenium WebDriver is a framework which we can readily use to interact with the browser and UI elements. Coming back down here, you have a choice of using different languages. This is a choice you have to make at the very beginning. Typically, we don't switch between what programming language we want to use once we start test development. So we have to make a choice in the early stage itself if you want to use Java as your programming language for test development. The other choices are Python and Ruby. So if you want to use Java as your test development language, then you will download Selenium WebDriver for Java and start coding it. So why Selenium? Why not other products? So it is a choice to be made. It's a decision that to be made on different factors. But why Selenium has become the most popular web automation framework is, one, it has been the largest user group support and it is open source, which means it doesn't have any royalty to pay if you use Selenium for your test development. And open source and user base. When I say user base, not the users as a test development, but more like a developers who contributes to the code of developing the WebDriver, enhancing the WebDriver. And number three, it has become a de facto standard for web application testing. So it's standard across the industry by all Fortune 500 companies to use Selenium in one way or other in their web development testing efforts. And one of the biggest development in the recent times is Selenium has been going through W3C specification, which is a standard across for HTML, CSS, JavaScript to be supported by different browser vendors. So if this specification finalizes, all of the browsers should support Selenium, which is the biggest advantage for Selenium WebDriver and its developers, so that it will become a standard across all of the browsers. Typically, as a test developer, you will run into issues dealing with different browsers with the code. Let us say I develop this code to test the username password screen right here, and it will work perfectly in Chrome. And if I want to test the same in a different browser, let us say IE, it will run into issues. And if I test it in Firefox, it partially works. And if I run in Microsoft Edge, it will have some other issues. So once it become a final approval approved for W3C, all of these browsers, vendors, Microsoft here, Mozilla, and Google should support Selenium once it becomes a standard. That will be a biggest celebration for test developers. There is one less thing to worry with the browser compatibility. To sum up this lesson, Selenium WebDriver is a framework to test browser-based applications. We have a choice to use different programming languages to develop our tests. Primarily, Selenium WebDriver helps to interact with the browser and UI elements, user interface elements inside the browser. With this, I conclude this lesson. You may now move on to the next one. Thank you. Hello, welcome. In this lesson, we will discuss about actually verify Java installation on your machine and download Selenium and set it up in Eclipse. First, let us start with verifying your Java installation, just to make sure you have Java and also verify where it is located. As a reminder, in our lessons, we're going to use Java as our programming language with Selenium. So we want to ensure we have the right version of Java is in place and set up the Selenium properly so that we can use to write test scripts. Go to your command line, start typing command in your start search, and at the command line type java-version. So you will get the version, whatever the version you have on your machine, and then let us make sure where it is located. So you can do where Java, which would give us the location where the Java location which you are currently using. So in this case, it's located at C program files Java JDK 1.8 bin java.exe. Just to ensure we are using the right version of Java 1.8 and the location of Java. Now that we are clear, we have Java version 1.8 and also the location, let us move on to setting up Selenium. First, we have to download Selenium from Selenium HQ website. So let us Google Selenium download Java, because that's the scripting language we want to use. It will take us to downloads Selenium, and in here you can notice there are different downloads for as per the language of choice. So for us, we are using Java as our scripting language with Selenium. So I would download this, or click on the download link here for Java. Go to your downloads folder. So you can notice Selenium Java 3.14 zip file in the downloads folder. We want to extract the zip file to a convenient location. So I will extract this zip file to C Selenium 3.14, just in case in the future if I want to know which version of Selenium I have downloaded, it will be easier if I name the folder appropriately with the version number. So I will name it like Selenium 3.14. Right click and extract all, and in here I will select Selenium Java 3.14 and extract. Now let us go to the C drive and see if we have that folder. And in here, in my Selenium-Java 3.14, you can notice these files are extracted here into this directory. So we have downloaded and extracted the files in the zip file to this location. Second step is complete. Third step is to use these files in Eclipse. So open up Eclipse, and for now I will use the workspace test auto, launch, and in here what we want to do is on this project expand the project and see what we have, and in the source I'll create a new package for Selenium. So I will name it as Selenium. That's a new package. So this is the Selenium package, and creating a package is not necessary, but once we set up the Selenium, I want to quickly test it. That's the reason I created a package. So you can go to the project level and right click and select properties and go to Java build path. In here we want to import the libraries, add the libraries that we have extracted to Selenium, Java Selenium folder. So here click on external jars, and you need to go to the folder where we extracted those files, which would be Selenium Java 3.14. Select those two jar files there, and again go back to the same location and select all of the jar files inside the libs folder. So we have added the jar files that are of Selenium. So here apply and close, and in the reference libraries we should be able to see our jar files that we just added. So these are all the jar files we need to use Selenium in our project. Great, so far we downloaded, extracted the files, and added the extracted files into Eclipse by, you can go back and rewind the video and see that, but basically we went into properties and Java build path and add external jars, right? So that's how we added them. With this, I will conclude this lesson. In the next one, we will verify our Selenium installation and also write our very first Selenium program. Thank you. Hey guys, welcome back. In this lesson, we will try to set up Chrome WebDriver and test our Selenium installation. Now, in the package I have created, I will create a quick class and name that class as test my Selenium. This is a simple class. The whole purpose of it is to test my Selenium libraries. So that's the class. I will write a main function, typed main and control spacebar, which would give you the suggestions. Something funky happened, but it showed up now. We have this empty main method. In here I will write a piece of code which uses Selenium. So in this case we will write 2-3 lines of code which will fire up Chrome browser and open google.com. Okay, so for that I need to start with the WebDriver. We will discuss WebDriver in detail, but for now, so this line of code is trying to instantiate a driver which is of type Chrome. Okay, so and let us mouse over. Probably we need to import them. So import Chrome driver. If you get this indicates your Selenium is set up correctly in Eclipse. If the Selenium is not set up correctly, if you're missing a jar file, or you don't have the libraries at all here, then you won't get these recommendations in Eclipse. Okay, so it says Chrome driver import. I will import that, and most likely it would be an import for WebDriver also. I will import that, and then driver dot get. Here I can do like https://www.google.com, which is like opengoogle.com. That's this line of code is doing. First of all, the suggestions that appear to import Selenium indicates Selenium was properly set up in Eclipse. And now let's try to run this. Run as, I'm sure it will run into a problem, but let's see, because I did not give where the Chrome driver is sitting. So we will talk about that in a moment, but I want you to see the exception, what we got. So here java.lang.illegal state exception. The path to the driver executable must be set by webdriver.chrome.driver. So here is the thing. We are directly saying we want to use Chrome driver, but we are not telling the script where the driver is sitting, right? First of all, what is the driver? Driver is the executable we need to download so that we can interact with the Chrome browser. Let us go to the Selenium HQ website one more time and download Chrome driver. This is not browser. The browser is already installed on your machine, right? The Chrome browser is installed on your machine, but this is a driver which interacts with the browser. We need to download that executable. When we are doing WebDriver lesson, we will discuss in detail, but for now remember we need Selenium downloaded and set up in Eclipse, and Chrome driver needs to be downloaded. So I will open up browser again. For the sake of the lesson, I will start with the search. So Chrome driver Selenium, and there are multiple ways you can download it, probably from Chrome driver directly from chromium.org, but I would rather go to Selenium HQ, and from here this is where we downloaded our Java, right? So this is our Java, and here these are all the various browsers that are available, and I'm interested in Chrome, Google Chrome driver, and in here I can get the latest version or previous versions. So I highly recommend spending some time on this website, because in some situations, you need to have a specific version of Chrome installed according to the guidelines in your company. Like, whatever they are doing, whatever the scripts are running existing, there might be a recommendation to get a particular version. Let's say Chrome, hey, we need to use Chrome 2.42, like that. We need to download that particular Chrome driver version. Since we don't have any restrictions for now, I will download 2.45. And here is the interesting thing. If you are on Windows, select the Windows. If you are on Mac, select the Mac zip. If you're on Linux, do the same for the Linux environment. For now, I'm on Windows, so I will select Windows and I download that zip file. And if I extract this zip file, there will be an exe file. So let us extract that file. So I have extracted the file to the folder Chrome driver _win32. This is the executable. So this is the path we are interested in. So we need to tell Selenium the location of this executable. So that is why we got this exception. The path is not mentioned. So the path to the driver executable must be set by webdriver.chrome.driver. So this is something I would like to copy it and go in here and do system.set property, and the key, paste that webdriver.chrome.driver, and the value, this is the value we want to provide the path to the driver. So the driver is located in C Chrome. Let us check one more time. I can rather copy this from here, copy, and Chrome driver.exe. So I will go back here and paste the path. You should also give the exe name here, Chrome driver.exe, and a semicolon, Control S. So what we did in this line is we're telling Selenium, hey, Selenium is looking for a property value for this one. Okay, so webdriver.chrome.driver. So what it is looking for is where is the Chrome driver located. So we give the path to the Chrome driver because that's what we are interested in. And now let us run this. Run as Java application, and you can notice the browser popped up automatically by the script and google.com is open. Let me run one more time. Close this guy, right click, run as. I'm not opening the browser, so just clicking on Java application, my hands off, and it opened the browser and opened the google.com. Now I'm moving the browser to the center. So, and then let us do one more step here. Right after the get, let us do driver dot wait, Control S, right click, run as Java application. It should open and close the browser. It opened and closed the browser because we have used driver.quit. So this code, don't worry about it. We will discuss about WebDriver and we will discuss about various interfaces, that means methods within the WebDriver in the next coming lessons. But more importantly, what we have done in this lesson is verify the Java path, Java version, and downloaded Selenium and extracted it to a folder, and opened Eclipse and added those extracted Selenium jar files to Eclipse, which should show up here. And we have downloaded Chrome driver.exe from Selenium HQ and extracted to this folder and gave that location as a property, WebDriver.Chrome.driver property. So Selenium is expecting where is the Chrome driver located so that it can use the driver to interact with the Chrome browser. So these are 3 steps: verification of Java, download Selenium and set up an Eclipse, download Chrome driver and use it in the script. Okay, hope you got that. If not, rewind back and watch it again, because this setup is important. A lot of people get stuck in the setup itself. So watch it again if you want to, and make sure you set up correctly on your machine before going on to the next lessons. With this, I will conclude this lesson and you may now move on to the next one. Thank you. Hello, welcome back. In this lesson, we will discuss about WebDriver. WebDriver and WebElement are the most important APIs in Selenium. In this current lesson, we will focus on WebDriver. WebDriver represents the browser programmatically. Let us say if you want to interact with Chrome browser, you can instantiate Chrome driver using WebDriver, which will represent the Chrome browser itself. We will also look at the API of WebDriver. What are the various actions we can take using WebDriver API? So Selenium WebDriver makes direct calls to the browser using each browser's native support for automation. How these direct calls are made and the features they support depend on the browser you are using, which means WebDriver will make these calls to the browser. Let us say I'm using Chrome browser, and I will use a WebDriver for Chrome so that any kind of test script I write, like browser.open, browser.getURL, browser.getTitle, browser.getPageSource. I'm just giving you some examples. Any kind of interaction you want to do with the browser, the Chrome browser, that can be done using WebDriver interface. So if WebDriver is an interface, that interface is implemented into a class, whichever browser you want to interact with. If it is Chrome, you will be using Chrome driver. If it is Firefox, you will be using Firefox, and Internet Explorer, Safari, and few other drivers are available with Selenium. Keep in mind one important thing, which is native support for automation. Native support. What does that mean is Selenium and the browser developer, if it is Chrome, Google, if it is Internet Explorer, Microsoft, they have an understanding how the drivers interact with the browsers. So natively they get support. It is not externally getting support. Natively, that means they expose the API to the Selenium WebDriver so that you won't run into issues. In the first lesson, we have discussed about W3C specification for WebDriver. You remember that? W3 specification for WebDriver means that all of these browser manufacturers should support Selenium WebDriver, which is the biggest win for Selenium, because all of these browser manufacturers support Selenium, then there will be less issues interacting with their browsers. Previously, it is not the case. They don't have native support. So Selenium has to deal with ever-changing browser features. Whenever something changes in the browser DOM or how it functions, Selenium used to break. If the native support is available, whenever something changes, those APIs are exposed to Selenium, then Selenium updates the calls. How important the native support is. So in here, we can see the Selenium WebDriver can instantiate different types of WebDrivers, which can be of type Chrome, Firefox, Internet Explorer, Microsoft Edge, Safari, and Opera browser. Different kinds of browsers. So simply in this case, what you will be doing is you will be writing code something like WebDriver and give it a variable name driver equals new Firefox driver. So the browser that you want to interact is Firefox driver. This is how you will instantiate the driver. And again, if it is going to be a Chrome browser, then you will be using Chrome driver. So that means we have created a driver object which is of type Chrome. So whatever interactions you want to do on the Chrome browser, you can simply do driver.get page title. We will look at the API in a little bit and explore the different kinds of methods you can call on the driver. So at a given time, you can assign whatever type of browser you want to interact with. Now let us take a look at the APIs available for WebDriver. You can simply Google Java Selenium API, and most likely this first result here, and now do Control F and search for WebDriver, and look out for in this left hand pane here, and we can do enter key and you can get to the WebDriver interface here. WebDriver interface. So this WebDriver interface is implemented by, like I said, Chrome, Edge, Firefox, Internet Explorer, Opera browser, Safari driver. All of these drivers are implemented classes of WebDriver interface. So like we have seen on the blackboard, we can use any kind of browser you want by instantiating that driver. Here we have used Firefox, or if you want to use Chrome, you can use as a Chrome driver, but you should make a decision which browser you're going to use in your application testing. Now let us take a look at the available methods on this WebDriver. So the WebDriver, one more time, it represents the browser. Keep this in mind. The WebDriver interface represents the browser. So whenever we say WebDriver, it is basically representing a browser. A browser should come into your mind. So what you can do on a browser, you can close a browser, right? And you can find element on a browser, like use text field, radio button, checkboxes, you can find them, right? Or find elements, plural, which is like multiple checkboxes are there, you can find them. And you can load a web page in the current browser window, like you can get to an URL, like access a website. So if you do driver.get http:// www.google.com, the WebDriver will fire up the browser, and get URL will get you the URL. We will see most of these methods programmatically just to give you an idea what are the various possibilities using the WebDriver interface. You can get the title, page title, whatever the title of that page, and you can do a navigate, quick, and switch to. These are the various options. Go through this API documentation and read through the description it has provided. That gives you a good understanding. But primarily WebDriver we will be using a lot is get, so that you can get to your application and find element and find elements and browser.close and quit. There will be an interview question. What is the difference between close and a quit? So a close would be like closing the current window of the browser, whereas quit is like closing the browser and all of the associated windows. Let us say you're working on an application that has a pop-up window, right? So you are navigating to the pop-up window and you want to close only the pop-up window, not the main window. Then you will use close. If you want to close everything associated with that browser instance, then you will be using quit. So it completely closes the main window and also any associated pop-up windows. We will conclude this lesson here and start on using WebDriver in the next lesson. Thank you. Hey guys, welcome back. In this lesson, let us see WebDriver in action. I'm opening up Eclipse here. In initial configuration lesson, we have set up Eclipse to use Selenium libraries and created a sample of code which opens up google.com and closes the driver, quits the driver. And now let us create a new class file to keep it separate so that it helps you to differentiate the lessons. I'll create a new one just for the WebDriver demonstration. So under the Selenium package, I'll create a new class WebDriver. Not to confuse with the WebDriver interface, I will include demo at the end. WebDriver demo. And in here, let us start with creating a main method. Main control spacebar. Select that top one, and I have the main method here. I don't want to type again. Let us grab the code where we did the initial setup for Chrome driver from our test myselenium.java class file. So I will get this and probably including accessing the website. And one more short key I would suggest is Control-Shift-F, which kind of gives us the formatting. So if I do Control-Shift-F, it formats us with the code. It is not so prominent. Let me try doing something like wacky lines of copy and paste, right? And then I will do Control-Shift-Format. You see that it adjusted the indentation for us. So Control-Shift-Format, and then I saved it. So this particular program main purpose is to focus on WebDriver methods, right? So WebDriver, we have instantiated a WebDriver object. The name is driver and we are using Chrome driver. And the first method we are using with the driver object is get. So always keep your API handy. That really helps you to look back what we are doing. So if you look at get, loads a new web page in the current window. That's what that particular method would do. So right after this, what we can do is get the title of the page, right? So that's interesting for us. And then we will try get current URL. And then probably let's see what makes sense in the current situation, like the learning situation we are in. And we will do get page source, which is not so important one, but just for the demo purpose. So let's get to the get title and get current URL. So we were there at getting the opening the google.com. Then I will do get title. To refresh your Java memory, so get title is returning a string data type. So it's returning something for us. So, and you should be prepared for that if you want to use it. So since it is returning a string for the title, I will print that out to the console, right? Otherwise you don't know what the title is. Of course you can debug, but for convenient purposes I will sys out that title. Syso control spacebar. I like shortcuts. It saves a lot of typing time. Get title. So we got the title. Now let us do what? I combine both of them into one line of code. I'm not passing into a string and then printing out the string. I'm directly printing whatever the output comes from driver.getTitle. So now let us say driver.get current URL, right? And you want to include the same sysout for this current URL also. Control S, and let us run this at this point of time. Right click, run as Java application. So Java browser is fired up, and since we are not closing the browser, it will stay up there. So let me close it myself. We will add that line of code also in a moment. For now I need to manually close it. I'm closing it. And you can notice here title of the page is Google and the current URL is google.com. So both of those are printed. So if you go back and check the title of the page, so this is the title of the page right in the corner of this window on the tab. So we are getting that information by using the method driver.getTitle. This comes in handy when we are testing the applications. So before, if you do any kind of testing like searching functionality of Google or verifying the links of google.com, you want to make sure you're on the right page, right? So one thing to do is get the title of the page. Let us say the website has common title across it. Then you need to check on anything else that you want to grab and make sure you are on the right page. So the get title comes in very handy. And current URL gives us the URL we were on. And now let us get the page source, which will be the source of the source code of that page, HTML page. which might be, large amount of text. So I'm doing driver.getPageSource. I will just differentiate this. It's page source. And to concatenate, I need to use the plus, Control S, right click, run as Java application. It fires up the browser, gets the title, and gets the current URL and the page source. I'm minimizing it now. And here you can see a lot of text has been printed out to the console, right? So this is the source of the page. So which means, let me open up the window again. It is as like doing view page source. Once you do view page source, you will get the source code behind that HTML page. It's usually a combination of 3 things at minimum. One is HTML, JavaScript, and CSS, cascading style sheets. So normally, like I said earlier, you won't be using page source very commonly, but get title, get current URL, driver.quit or close, those are the more common methods you will be using. And the top of all of this is driver.findElement, which we will save it for later lessons, but I will conclude this lesson by using driver.quit so that we have experienced different kinds of methods within the WebDriver. And here driver.quit. I would use quit if I'm sure I'm done with running the tests. So Control S. There is no pointing in sysout, right? We are just quitting the driver. For the matter of knowledge, I will mouse over on the quit, and you can notice driver.quit is returning void. That means it's not returning anything. So that's why the println gives us this little error notification, because it's not returning anything back to us. Remove argument to match println. So there's no println is expecting a string, but nothing has been returned, so that's why it's complaining. So I'll remove. There is no point in printing it out. Control S, right click, run as Java application. Now this time the browser closed at the very end of the test we are doing. So in WebDriver API, we have seen close and quit are similar in the sense, you want to close the browser. Like I mentioned, close is more for pop-up windows. You want to save the parent window. You don't want to close the parent window, but the pop-up window, then you will be using close. Quit kind of closes everything, the WebDriver itself. And we have seen get current URL, get page source, getting the page source of the web page, get title of the page, and from Selenium test automation point of view, find element is most commonly used. We will do when we are doing exercises. Basically, we're trying to find if you want to enter something into the Google search, right? And you need to know this element, whatever this web element name or ID is, to really enter some value. So for that, we will be using find element. So for now, I will conclude this lesson you can practice using these different methods available on WebDriver. And in the next lesson, we'll talk about web element. And then we will come back to driver.findElement, because driver.findElement deals with returning a web element object. So we need to learn about web element to fully understand how to use driver.findElement. That is the reason I'm saving it for upcoming lesson. With this, I will conclude this lesson. You may now move on to the next one. Thank you. Hey guys, welcome back. In this lesson, you will learn about different browsers supported by Selenium WebDriver. The best place to check which browsers are supported is by going to Selenium HQ website. Before we get into details, let us see how WebDriver acts as a middleman between browser and your script. Three main players are involved when we are writing a script to automate web testing: the script, the WebDriver, and the browser. The script is the code you have written, the WebDriver is the executable, and the browser. The role of WebDriver is to interact with the browser based upon the instructions passed by your script. So Selenium supports Chrome, Internet Explorer, Mozilla Firefox, Safari, and few more web browsers. Chrome is highly popular and it is being used by most users. Let us assume we want to test on Chrome. Then we have to download Chrome WebDriver. Let us be clear. Chrome WebDriver is an executable that Selenium uses to interact with the real browser. So you should not be confused between Chrome WebDriver and the Chrome browser. On the other hand, if you want to test on Internet Explorer, then you need to download Internet Explorer WebDriver, and of course we need Internet Explorer browser itself. Again, Internet Explorer WebDriver is the executable which interacts with the real browser, which is Internet Explorer. So we need both the browser and also the driver to run the tests, and of course your script. You get it? Remember, in our script we are giving path to Chrome driver. That is where the Chrome WebDriver is copied to. So if you want Internet Explorer driver, then you will copy it to a certain location and give the path to the script. So the script uses the driver to run the tests on the actual browser. So the WebDriver executable is the middleman. Sometimes this gets tricky. The version of the driver executable and the browser version will have compatibility issues. Let us say I downloaded the latest version of Chrome WebDriver, which is currently 2.45, and the Chrome browser version I'm using is 71.0.3578.98. So the compatibility between the Chrome WebDriver and the Chrome browser is important. My tip for you is disable automatic browser updates so you won't run into issues all of a sudden whenever the browser updates happen. If you don't disable the browser version updates whenever they push a minor version to the browser, the compatibility between your driver executable and the browser might fail. So to have a better control of your versions, disable automatic updates for your browser. Hey guys, welcome back. In this lesson, we will see how to set up IE WebDriver for using Internet Explorer browser in our tests. In the previous lessons, we have used Chrome driver. Right after Chrome, IE browser is the most popular, especially with intranet applications. So the applications which will be used within the organization. First, we need to download IE driver server from Selenium HQ website, and we can place it in a folder like C:IE WebDriver. Simply, we can just Google Selenium HQ IE WebDriver. And in downloads, you can look for 32-bit Windows IE, 64-bit Windows IE. In our case, I will be choosing 32-bit Windows IE, which is absolutely fine to use in 64-bit Windows operating system. The reason I'm not going with 64-bit is it has some known issues with it as of now that may change in the future, so feel free to research a bit before you download. For now, I'm clicking on 32-bit Windows, and we will get a zip file here, and you can extract the zip file to C:/IE WebDriver. That's what I'm going to do. Right click, extract all, and I modified the path to C:/IE driver and whatever the default folder it gave in the extract. I want to keep the version number intact because in the future, if I want to use a different version of the driver, I can still keep this folder, and also more importantly, keep track of which version we are using. That is very important in using drivers, because you will run into compatibility issues. The browser version you are using and the driver version you are using, this is the typical compatibility issues. It's always a good idea to save the driver version in the folder name itself. Now let's extract it. So here is our IE driver server.exe, and it is located C:/IE driver server win32 3.14.0 IE driver server.exe. Let us right click on this, look at the properties, and let us see if we have any information. Yeah, this is what I'm looking for. The file version, just in case you were not able to store it in proper folder name, or simply you stored it under IE driver, you don't know how to find out the driver version, then you can right click on properties and go in here, and you can check for file version, and you will get that file version. Okay, this is the secondary option you have. All right, now we have this driver exe downloaded. Let us start with creating a new class in Eclipse and use IE driver instead of Chrome driver for our test. Okay, here I'm in Eclipse, and under Selenium package, I'm going to create a new class, or you can also do a testng class. For now, let us keep it simple here. A new class by name IE driver test. And I will select this method, main method. Now let me copy the basic code that we have used for Chrome, and that way we will focus more on how to use IE instead of Chrome, not coding again from scratch. I'm copying the code from WebDriver demo.java to IE driver test. And in here, we will be modifying these 2 lines of code. That's it, so that we can use IE as our web browser for testing. So for the system.set property, instead of Chrome, we are using IE. So replace it with IE and modify the path so that it points to wherever the IE driver is located. So I can copy this path from here, and we need to provide the exe name also, which is IE driver server.exe. And save this file. Since we are going to use IE WebDriver and IE browser, we need to modify what driver we are instantiating. So here, instead of Chrome driver, this is supposed to be Internet Explorer driver. Most likely it will recommend to import the driver. Import Internet Explorer here, org.openqa.selenium.ie, and let me save this file here and run it. Right click, run as Java application. We should see IE fired up. There is the IE, and we got an exception. Let us see what it is. This is the fun part. So if I scroll up, no search element exception, which is not able to find title equal to search and type is text. Okay. So it's not able to find the element on the web page. It's nothing wrong with firing up the browser itself, right? So let me see what we can do about it. First of all, let us check the code, because we are simply using this code from our previous script. Let me do one thing. Instead of using XPath, I will switch back to using find element by name, this line of code. Okay, that's a quick test to make sure if it is really XPath problem or is it another problem, because here no such element exception is what we are seeing, and it is having trouble finding by XPath, right? So we need to try use different resource locator to find it. Now we are trying to find it by name. Right click, run as Java application. Still we got the same error. Let us see what it is. Okay, I took the problem offline, and one little tweak we need to do for Internet Explorer while we are running automation tests. That is basically in the security settings, we need to enable protected mode for all zones. Let us see what it means. So let me open IE. In Tools, Internet Options, you go into Security, and in here, enable protected mode should be enabled for all zones. For internet, it's enabled. For local intranet, it is not. Now I'm enabling it. And trusted sites, I am enabling it. Restricted sites, it's already enabled. But make sure it is enabled for all of the zones. Then apply. Okay. Close the browser. Now let us try to run it again. Right click, run as Java application. So the browser is fired up and Google is the title and URL we got it. Let me comment out the driver.quit so that we can see the page up there. Right click, run as Java application. testautomation.co, clicked on search button and we see the search results. So coming back to our code, to summarize, we have provided WebDriver.ie.driver and the path where it is located and instantiated with Internet Explorer driver. Apart from that, we made a tweak in the options so that to make sure all of the zones are in protected mode. Internet, local internet, trusted sites, restricted sites, all of them are enabled for protected mode. This little tweak get rid of the exception we saw for no such element. I will check in the code, try it by yourself and let me know how it goes. With this I conclude the lesson, setting up IE driver in Selenium. Thank you. Hey guys, welcome back. In this lesson, Introduction to TestNG, we will discuss what is TestNG, why we need it, and when we will be using it. Let us start with what is TestNG by definition. Then we will go into more details. TestNG is a testing framework for Java programming language, created by Cedric Bust and inspired from JUnit and NUnit. The design goal of TestNG is to cover a wider range of test categories: unit testing, functional, end-to-end, integration, etc., with more powerful and easy to use functionalities. As a starter, the definition will not make full sense. One gets an idea, it is used for a wide range of testing types. Let me present you a scenario, followed by a problem and explain how TestNG solves it. Let us say you, me, and couple of other test developers created 100 test cases. We decided to run few as part of smoke testing and some as part of regression testing. And also let us assume you wrote code using a main method in your test scripts. That is how you will write if you don't use TestNG or similar framework. Let me repeat. We wrote 100 test cases together, out of which some we want to run as smoke tests, some as part of regression tests. And these 100 test cases have their own main method by each individual test developer. That's the scenario. Now, your lead will come and say, team, let us only run smoke tests for each build. You should do full regression once weekly. So which means you're running the smoke tests for each build and regression tests only weekly. The reason behind it can be the regression tests will take a very long time to run. So how will you classify your tests into smoke and regression tests without spending hours of coding and classifying them? The answer is TestNG. TestNG uses annotations. By adding groups parameter to annotation, you can classify tests into different categories. For each, you provide a group it belongs to. So you can give a group as regression, a group as smoke, so that from your command line, when you run these tests, it will only run those groups One thing you ever want to remember about TestNG is annotations. What again? Annotations. The annotations with @ symbol. We will see how to implement in the following lessons. Second solution TestNG provides is test lifecycle management. So when you're running a test, we will fire up the browser, we execute search or whatever test you want to do, and then you will close the browser, right? So in this test lifecycle, if you classify them at a high level, 3 steps are involved: firing up the browser, running the test, and closing the browser. So this lifecycle can be elegantly managed in TestNG using annotations. Yes, again annotations. So you can use @before, @after, @test annotations for these 3 steps of lifecycle. With test lifecycle management provided by TestNG, we can get rid of main method, what we are using so far. Instead of main method, you can write your methods as @before, @test, @after for firing up the browser, running the test, and closing the browser. Main method is still a good thing when you are learning and testing few things real fast, but in professional test development, we will not be using main method. Either you will be using a test lifecycle management like TestNG or JUnit to execute the tests. To sum up this lesson, we use TestNG for test lifecycle management and also to group the tests into different categories like smoke, regression, and sanity, whatever you want to group them as, all with annotations. Thank you. Hey guys, welcome back. In this lesson, we will set up TestNG in your Eclipse and verify proper installation of TestNG. It is relatively easy to get your TestNG going. We can install TestNG in 3 ways. Let us see what are the different ways you can install TestNG. Number 1, install via Eclipse Marketplace. Number 2, install by drag and drop, again from the marketplace. And number 3, using update site in Eclipse. Approach 1, installing via Eclipse Marketplace. Open up your Eclipse, go into Help menu and click on Eclipse Marketplace. Here you can search for TestNG. The search results are showing multiple of them. Look for TestNG and also notice it is by Cedric Bust, the creator of TestNG. Now you can click install, which will add the plugin into your Eclipse. The second approach is again using Marketplace, but we are going to the Marketplace web page and drag and drop the plugin. First, Google TestNG Eclipse plugin, and maybe you want to add Cedric Bust so that we can get correct result. Once you are on the page, you can simply drag and drop this tab into your Eclipse workspace. It pops up Marketplace dialog box, and you can select and move on to install the plugin. Now the third approach is by using install new software from Eclipse itself. For this, you need to know the URL beforehand. A simple Google search will give you the update site. So search for Eclipse TestNG updates site. Then you get this URL. Go to your Eclipse help install new software. In the field provided, put in the URL and select TestNG. Move on to install the plugin. You have to accept the terms of use, and then it will prompt you to restart the Eclipse to complete the installation. Once you restart, we can see TestNG library added to the Package Explorer, and you should be able to create a new TestNG class. So let us verify these two steps to make sure our TestNG is properly installed as a plugin for Eclipse. Step 1. You should be able to see TestNG library added to the packages. This is pretty straightforward, and it is here in the Package Explorer. And the step 2, to verify if you can create a new TestNG class. For that, right click on the package and select new, and select other and type TestNG, so you can see a class that you can create of type TestNG. Click on that. It will create a new class with the name you provided, with a basic method with a test annotation. So this means our TestNG is successfully installed into Eclipse. Well, in this lesson, we have seen 3 different ways to install TestNG and 2 steps to verify successful installation of TestNG plugin. In the next lesson, we will work on creating test cases using TestNG. Please go ahead and set up your Eclipse so that you will be ready for the next lesson. With that, I will conclude this lesson. Thank you and have a good day. Hello, welcome back. In this lesson, we will discuss about Web Element. Web Element is the most used API along with WebDriver. In the previous lesson, we went through WebDriver. WebDriver represents the browser. Any action you want to take on a browser, we will be using WebDriver. To recap a little bit of your memory, WebDriver typical methods are WebDriver.findElement, WebDriver.close, WebDriver.quit, WebDriver.getTitle, which gives us back the title of the page, right? So these are the various methods. Web Element, on the other hand, helps us to get a specific element on the web page. So let us say the web page has a simple username, password, elements, and a button to submit. So you can enter username and password and submit that page. For that, if you want a reference to the username text field, and if you want reference to the password and then reference to the submit button, you will be using web element. So in plain English, we can say a web element represents all of the UI elements present in a web page. If you are familiar with HTML, hypertext markup language, the web element represents the elements such as text box, drop-down list box, radio buttons, checkboxes, etc. I will do a separate lesson for HTML and DOM, but right now we don't need that information to progress this lesson. So let us check the API of web element and see the available methods similar to what we did for WebDriver. Just a quick stop before hitting the API. For the definition, web element represents a HTML element, generally all interesting operations to do with interacting with a web page. So let's take a look at the API for web element. Simply Google for web element, and our language of interest is Java, so web element Java. You can add Selenium, and here we can see a couple of options. I'm trying to look at the same API, but let's go with the first result here. So represents HTML, whatever the definition we went through before, but we are more interested in the methods that are available on web element. So here we have methods like clear, click, find element, find elements, and get location, get tag name, get text, is enabled, is selected, send keys, submit. I just gave you some of the important ones here. I highly recommend going here and going through each one of these methods. Even if you don't use them on a regular basis, go through them once so that it stays. You will get a feel of that you went through it. But important ones are always that we go through. So here, when I say a click method, you can visualize clicking something on the web page. That action will be performed by this method. And let us see if we can find another interesting one. So these two are the most used and interesting ones. Send keys. Let us see what the definition says. Use this method to simulate typing into an element which may set its value, right? If you're entering an username and if you're entering a password, this is the one you should be using. Send keys. So use this method to simulate typing into an element. So, and submit. If this current element is a form or an element with a form, then this will be submitted to the remote server. So the submit method will help us to submit the form. After you enter username and password, you will submit the form as a post to the server. So you will be using .submit with that whatever button you are trying to click on. Now let us take a look at existing code. We might have used web element already, and we will enhance that script to use other important methods in the web element. It seems like we haven't touched web element in our previous example, which is a good thing. We can start from scratch. So WebDriver we are using here in this example is Chrome driver and trying to get google.com, and also trying to get the title of the page, get the current URL, and get the page source. So on this web page, we opened up the driver. We did a driver.get actually to open up the web page, and get title will give you back this title of the page, and get current URL will give you the URL, which would be google.com. Let me go back to the google.com to keep the URL clean. And get page source, which would give us back the page source of this particular google.com page, all the source code behind it. These are the three things we tried using the WebDriver. Now let us take it to the next level. We want to use web element to interact with the elements inside the browser, right? So inside the browser, which would be this text field and this button are the typical. You can find multiple other links around here on the web page. Let us focus one at a time. So using web element, I want to search for a search term using this text field here. So for that, I have to use web element. So if you want to call a person or somebody, what we will use? We will use their name, right? Or sometimes if you are waiting somewhere and your number will be called by, let us say, the bank teller will call your number so that you can approach the teller. So there should be some kind of identification to call somebody. At the same time, and similar to that, we need to have some kind of identification to use this text box, because program does not know which one to interact with. You need to specifically tell what is so unique thing about this text box. Does it have a name or some kind of ID, right? One of those should be there. Then only the test script will identify that particular UI element. In this case, we will do a simple way of finding out something unique about this text box here. And as we discuss in the future lessons about resource locators, we will go in depth. But for now, what I will do is, in the Chrome browser right now, I will right click and do inspect. And inspect would open up a developer console, a developer window here on the right side or at the bottom. It depends upon how you set it up. By default, it comes on the right side. So I can use this little icon here to point to whichever element I'm interested in finding the name, right? I use this little arrow from Chrome developer and pointing it to the text box here. I will click on that. And here you can notice that particular element has been highlighted. So it's an input type and it has a class and bunch of other stuff, but I'm interested for now on the name of this text box, right? The name of the text box is Q. So that's something you need to remember. So you can keep it open and go to your script, but for the lesson purposes, remember the name is Q. So now let us go into the code and see how we can use the name of this text box to enter some value into it. We will end the lesson here, and in the next lesson, we will see how to use find element and access the search box. Thank you. Hey guys, welcome back. We will continue with web element. We are going to use web element to really access this text box by using its name. For now, I will comment out this page source because it prints out a lot of page source into our console. So I will comment that, and in the next step, what I would do is driver dot find. It's a little slow in responding. Find element, and it takes an argument. We will go back into our API and verify what are the parameters and everything. For now, follow the code by dot will give you bunch of options. So different ways to identify the text box where you want to enter the value, right? So but what we know is we know the name of it. So I would choose the name by name. And what is the name of the text box we found from the Chrome developer tool? It is Q. So by name Q. So in this particular step, we are telling the driver, go find element by name Q. So if you mouse over the find element, that is important as a programmer. You want to check what it is returning back to you, right? So when I mouse over, I can find that this particular method, find element, is returning back web element. This is what we are interested in. This is how we are going to get reference to that text box. Otherwise, it's finding and we are not doing anything. We want reference to that so that we can enter some value into it. So I would do web element is what it is being returned, and you can give whatever the name you want to, because it's a search box or whatever. That's what I want. We named it as search box. And now we need an import. If you mouse over here, import web element. So I will select and import that class and search box. Now let us type search box and see what are the available actions you got. These are nothing but all of the methods available on the web element, which we have seen a little while ago, right? In the API. So here, send keys is the way to enter values into the text box. So this is why you need to read through the documentation. So you will get familiar two ways. One, practice the code, and read the documentation, read the API. So I will select the send key, select that, and what I want to test on is test automation .co. Let me remove the space. So we have used the web element, which is a search box dot send keys. That means the send keys is doing the magic of entering the value into the search box. That's where we are doing the real automation. We are programmatically entering the value into the search box. So you can do all of the next steps using either WebDriver or web element. I don't want to oversimplify the Selenium, but pretty much revolves around WebDriver and web element. There are other things we need to learn, such as resource locators, which is very important on complex web applications. We will cover that in upcoming lesson. But for now, you can get a simple and basic understanding using these two classes, WebDriver and web element. Now let us run this code and see the result. Right click, run as Java application. I did not save it, so it's prompting me to save, and it continues to run, and the browser is, wow, it went too fast. So what I will do is I will remove this or comment out the quit, right? Because it's closing the browser, we don't know what happened, it went so fast. So I don't want it to be closed so that we will get a chance to look at it. Control S, I will save it and right click, run as Java application. So it entered test automation.co. See, that entered there but never clicked on Google search, right? We will take it to the next level now. Okay, so it entered and that's where it stopped because we did not instruct anything further in our code. So next step would be clicking on Google search. Let us do that. So let us inspect for the name of this button, some kind of ID. So inspect, and we can see you can use this little arrow here and mouse over Google search and it will highlight here. So here it's input value Google search and name is btnk. So that's what we want. So I will copy that and let's go back into our code. And here we want to find the element, right? So temporarily I will paste there, and it is basically finding that element. This element is, I will call it as submit search button, btn. Okay, and driver.find element by name is still good, so this time the name is btnk. Enter. Submit search button dot, so bunch of options. Click, find elements, get attributes, and all of those. And here it's a submit button, so I would submit it. So submit, since you don't have to pass in any parameters, it's basically submitting that particular form with the search box value. So Control S, right click, run as Java application, Chrome browser, typed in the value, clicked on the search, and we got the search results, right? And we did not take any further action. We got the search results. Now you can take it further by clicking on whatever you want to and going from there. So we have automated the process of entering the search term and clicking on the button. With those two, we were accomplished getting the search results. So web element is so familiar, is so important in Selenium test case development. The API documentation is something you need to refer back, and all the available options in the API. So with this, I will conclude the intro lesson. In the next lesson, we will go in depth about using other methods on web element. Thank you. Hey guys, welcome back. In this lesson, we will discuss about HTML, Hypertext Markup Language. This will be an introductory lesson. You will be learning HTML syntax and common HTML elements. Let us see the definition and HTML code for popular elements such as text box, submit button, links, radio button, checkbox, and drop-down list box. So HTML is the standard markup language for creating web pages and web applications with cascading style sheets and JavaScript. It forms a triad of cornerstone technologies for World Wide Web. So all of the web pages we see online are made of three technologies. From the user interface perspective, they are HTML, CSS, and JavaScript. Here we are interested in HTML from test automation point of view. That is a main. script that creates the UI elements inside a browser. So in a browser, if you do right click and view source, you will see the source code behind that page. It will have combination of HTML, JavaScript, and CSS, cascading style sheets. CSS is used for styling the web pages, and JavaScript is used for dynamic HTML. When you mouse over certain image or a link, the color changes or pops out. All dynamic action are created by using combination of CSS and JavaScript. Here we are interested more in HTML. From test automation point of view, we need to interact with these UI elements when we are writing the code. So everything in HTML is a tag. HTML starts with HTML tag, and other main tags in HTML are head, body, form, anchor, and input tags. Let us take a close look at HTML sample. Here we can see it is started with HTML tag, followed by head tag, then a body tag, and the body tag will have other HTML elements. If you want to run a HTML file as a standalone, you can copy this code into a text file and change the extension to .html. So instead of .text, we will be changing it to .html. Let us copy this code and create a .html file, a sample.html file. When I double click and open this sample.html file, we can see the UI elements in it. By the way, this is not a fancy page because we are not using any JavaScript or CSS in this case. Each type determines which UI element it represents. It can be checkbox, text box, radio button, link, drop-down list box. I will provide some more links outside of this lesson so that you can explore and create your own HTML page. With that, I will conclude this lesson. You may now move on. Thank you. Hey guys, welcome back. Hope you're doing well. In this lesson, you will learn about interacting with radio buttons. Using Selenium web element, we will script click and toggle radio buttons. First, let us see what a radio button is and its HTML code. A radio button or option button is a graphical control element that allows the user to choose only one of a predefined set of mutually exclusive options. The HTML snippet we have here represents 4 radio buttons. You can see type equal to radio makes the element a radio button. You can notice name is same for all because they belong to one group, which is group of browsers. Let me copy this snippet into a text file. Rename the .text to .html so we can see it in the browser. I'm opening this file in the browser. We can notice 4 radio buttons created with Chrome being selected. That is because we have added checked attribute to Chrome option. So are you wondering what happens if you add checked option to multiple radio buttons? Well, you check that by yourself and let me know. Now that we have seen how HTML code looks like for radio button, let us get into the code. Opening Eclipse, create a new class, radio button example. So this will be a testng class so that it is easy for test management. Before we can start coding, we need a sample page to interact with. So I have created a simple HTML page hosted on testautomation.co, which has radio buttons, drop-down list box, checkboxes. It is located at https://testautomation.co/web elements. So you can use it for practice purposes. I will be updating this page with more UI elements as we go. Now back to Eclipse. We will create a testng class for interacting with radio buttons. Remember, we are no longer using main method. I will copy some of the code which deals with instantiating the browser and closing the browser. It saves some time. Now, using driver.get, we will access our web page. We will find radio buttons by name. Let us use Google Chrome Developer to inspect for the resource locator. Radio buttons are a group, so they share the same name. For dealing with radio buttons, we need to get reference to all radio buttons in that group, and then you have to click on a particular one. Usually find element is used to find HTML element on a web page, right? If there are group of elements sharing the same name, you will be using find elements, since we are getting back a list of them. Quick note, the API of WebDriver for find elements, if we look at it, we can see list is returned. That means a collection of UI elements will be returned when you are using find elements. That makes sense. In our case, it would be collection of radio buttons. Again, you have to refresh your Java skills. We have a lesson on collections in Java course talking about lists and hash maps. Here we are going to use lists. So we are using find elements by name, and we will be getting back a list. At this point, let us set a goal for us. We have a goal of, let us say, clicking on selecting IE radio button. By default, Chrome is selected. For our test case, we need to switch it to IE. That is our goal. So we can do driver.findElements by name. Here the list will be returned back consisting of radio buttons. You can access the list by index, right? So if my goal is to select IE, I can use index on this list and simply click on IE radio button by index. So the position of IE in the radio buttons is second position. In indexes, it would be 1 because indexes start at 0. So 0 is Chrome, 1 is IE. I can do browser radios dot get 1, that is IE, dot click. This should select IE for us. Quick and easy fix. Let us run the code and see. We can see the browser is fired up and radio button IE is selected. Let us take this code one level up. Since we are doing by index, what if developer changes the position of IE in the radio buttons? Then script will not work as intended. It will select whatever it is present at index 1. It may be IE or may not be IE. Right? To make our script more robust, what we can do is check the value before clicking on the radio button. So if the value is IE, then only click on it. To get the value, we will be using getAttribute method on web element. Since value is one of the attributes of radio button element, you can use getAttribute to get the value of that particular radio button. So for that, we have to iterate through the list. So we will create a for loop that goes through the web elements, and let us print the values first with a sysout. I'm running the script as testng, and we can see all of the browser names are printed out. Now we have more control. I can click on a radio button based on its value, not by position. So radio.getAttribute value equals to IE. Then click on that radio button. Let us run the code again. For that, I will comment out the previous click we have done on IE so that we are not mixing up. When I run this code, we can see IE is selected, this time by value, which is more clear than clicking by index. With this, I will conclude this lesson. Practice this on your own. Try to select a different radio button, try to print the attribute values, and print the names. Thank you. Hello, welcome back. In this lesson, we will discuss about resource locators. Selenium uses resource locators to find the exact element on a web page. In our previous lesson, Web Elements, we have used resource locator by name of the search text box. So we can see here when I do inspect, and we have used the name as the resource locator, and we haven't discussed about the resource locators at that point of time. Now we will see what are the various types of resource locators. Name is one of them, ID is one of them, and you can find by XPath, and you can find by CSS. There are different ways to find an element on a web page. And of course, there is an order of preference, not a strict one, but if there is an ID available and that ID is unique in the web page, that would be the first choice. And same applies to the name. If the name is unique in that particular web page, then name would be the second preference. And most commonly in the recent times, the web pages are developed using some sort of JavaScript libraries. So it makes it harder to have a unique and consistent ID and name for UI elements. So XPath has been more frequently used than any other resource locators. We will start with ID and name, and then we will look into XPath. Let us do a quick recap on WebDriver, Web Element, and Resource Locator. So anything you do with the browser level is what the WebDriver does. So driver.get gets the URL for us, and driver.find finds the UI element for us, and driver.close will close the browser. These are the typical methods we use on a WebDriver. When it comes to web element is returned when you do a WebDriver.find element, and it returns as a web element, which can be a text box like this, and it can also be a search button and any kind of buttons, any of those UI elements you see on the web page. Those are web elements. Now the current lesson, which deals with resource locators. Resource locators are used by WebDriver to find an element. So if WebDriver wants to find an element to enter the testautomation.co in the search text box, it has to do driver.find element, and then basically we want to provide a parameter by what? By dot ID is one option. You can give the ID of this particular text box and 1213, then it will return the web element text box. And if you want to find it by name, you can do by dot name q, right? So these are the options we have, and like I mentioned earlier, ID would be the first preference if the ID is available, but with one big clause: only if this ID is unique on this web page. If some other element has same ID 1213, and that may not be a good option to use an ID. Or if this ID is keep on changing when the page refreshes, or whenever the new application comes, they keep changing the IDs, then also it's not a good idea to use an ID. So two things again. One is when we have multiple elements with the same ID on the same page, not a good idea to use by ID. As a matter of fact, not a good idea to use a resource locator which finds multiple elements on the page. And number one, remember as duplication. If you have duplicate IDs on the same page, don't use it. And number two, if the ID kept on changing whenever you refresh the page, or whenever the new build comes up, the ID changes, then it is a problem, right? The next time when you run your script, if the ID is different, you won't be able to find that text box. So then also not a good idea to use an ID. And again, the same principle with the by name. You apply the same principle. If the name is unique in the web page, use it. And if the name is consistently available, the same value with the page refreshes or when the new build comes, if the name is consistently the same, then you can use the name. by name as your resource locator. What if these are not consistent? That's when we will look into the other options we have available. So one of the prominent one is by XPath. And also you opt for using XPath if there is no ID or if there is no name associated with certain input type, or some element does not have any one of those. It doesn't have the ID and also it doesn't have the name. Then you're left with the choice of using either by CSS or by XPath. So we will take a look at how to find an XPath, because XPath is not readily available as such, like ID and name are available. We have to use Google Developer Tool. That's one way. You can also use Firebug and Firepath to get the XPaths. We will try to use the most reliable way to get the XPath, that is using Google Developer Tool. I should say Chrome Developer Tool. We will end this lesson and start on using Chrome Developer for resource locators in the next lesson. Thank you. Hey guys, welcome back. In this lesson, we're going to see how to use Chrome Developer Tool for resource location. So on this text box, I can do right click and inspect, and we can see ID. That's what we have used in the past. I think we have used the name. It has both ID and name. Let us refresh the page, F5, and inspect one more time. ID is Q, name is Q. And so when the page refreshes, this ID is not auto-generated, that changes every time. So safely we can use ID or name in this case, but we want to make sure that it is not repeated in the same page. We want to ensure there is no duplicate IDs on the same page. So let us see how we can do that. You can use Chrome Developer Console to do that. Before we get there, two important things we need to see here is, once I did inspect this Chrome Developer debugging pane opened up, and here these two tabs are important from a test developer point of view. Elements will show all of the elements present in that particular page, and console is some debugging tool you can use to debug. For example, using console, I will be verifying if there is any duplicates for the ID on this page. So what I can do is, I can do like write a small command, document.get element by ID, and we know the ID is Q, I believe. Let us double check, but let us try with Q, and it said null. So that means there is nothing exists with an ID of Q. Let us double check, inspect, and let us go to that particular input type, and there is a name Q, but there is no ID. And what about the button? Inspect, and name button K is there. It seems like if you open Google from the home page to another different page like search results page, there might be a slight difference between how the ID and name are used. But anyways, our goal is we don't want to have a duplicate. What we saw is ID, which is equal to Q, does not exist because it returned a null here. So technically, if we look back here, but name value with q should exist. Let us go back to the console and do in this document get element by name. Let us try that, and the name value is q. Enter. I did something wrong here. It's not a function, is it? Let us say get element by name, elements by name. And we can see here we have only one element by name, which is equal to q. Okay, so to prove it otherwise, I want to test that something has multiple returns, right? So what I want to do is, what is common across all of these is input. Input is all over the document. So this is an input, it's a tag, right? And this is also an input tag. So input is all over the document. So if I look for a tag name input, it should return multiple of them. It's just to prove ourselves this is working. So document.get element, let us look for tag name. So this is the tag name, which I want to look for input type. This should obviously return us multiple of them. And so we can definitely see there are 8 of them here. 8 of them. So the length is 8. So there are 8 input type tags in this document. So when we look at this by name, there is only one. So this could be an eligible resource locator we can use because it's unique. It's unique in the page, right? And that's one rule success. The second rule is it should not be dynamically changing. And we have noticed with page refreshes, it is not dynamically changing. So 2 conditions met, we can comfortably use driver.find element by name or by ID. Both of them are fine, right? So that's how we come to a conclusion whether it is safe to use name or ID of a particular element. Let us assume this name is changing all the time. One time it says Q, next time when a page refreshes it says P. It is changing all the time. Then it is not a good idea to use by name. Then I would go for the other options, which would be my personal favorite, XPath. With this, I conclude ID and using name as a resource locator. We will see using XPath as a resource locator in the next lesson. Thank you. Hey guys, welcome back. In this lesson, we will discuss about resource locators, in particularly by ID. So resource locators are the way to find UI elements on a web page. Just to refresh your memory. So we use different kinds of resource locators like by ID, by name, by XPath, by CSS, by tag name, by partial length. The understanding of resource locators is so important. This is the concept you will be spending a lot of time in when you are really working in a project. So I will go in detail so that there are no doubts with the fundamentals. In Eclipse, let us start with creating a new class by name element by ID. I will be creating under Selenium package here class, and the class name is element by ID. Let us step back a moment. Here I'm creating a Java class, a regular class. We want to use testng. So let me cancel this and do right click, new, other, testng, and I will name this class as now element by ID, and I will also select at before method and at after method. So now we have a testng class with at before method and at after method and at test method. Let us reasonably name this test method. It is simply f right now. Let us make it like test by ID. And it doesn't matter in which order these methods are. Simply they will run at before method first and then test and then after method. But for the sake of clarity, I will move this at before method really before the test. And whenever this kind of indentation happens, you can use Ctrl+Shift+F so that it formats nicely. And Ctrl+S. Now let us copy and paste the code for at before and at after. We don't want to type again and again. So at before usually deals with the browser instantiation, and at after deals with closing the browser. So in here I added code into the at before method, simply instantiating the Chrome driver, and in at after method I have added driver.quit. So with that, let us start with writing the code for the test. Before writing the code, we want to know which element we want to interact with on the web page. So let us open the page that we want to interact with and go from there. Here is our test page, which is testautomation.co/web elements. I have made few changes to this page. I'm acting as a developer also in this case. So I have added few links here so that we can use it while we are doing XPath. For now, our goal is to use find element by ID. So we have this field here. Let us right click and do an inspect on it and find out if it has an ID. So it has both ID and name, and ID is legal name, name equal to your name. So we will use this ID to find this element on the web page and enter value. So that is the goal. So we're going to use ID equal to legal name as our ID. Let us jump back into Eclipse, and in here we can add on to this method driver dot find element by ID and the ID value is legal name. So we are able to find the element here, and once we got that element, what we need to do? We need to enter value into it, right? So what does the find element returns to you? If you mouse over there, you can find out whatever this method is going to return you. Return type on this one is web element. On the left hand side, to get the reference back of the name field, what I will do is, since it is returning web element, I will declare a web element and give name as its name. We need to import web element since we are using it for the first time in this class file. Control S to save it. And now here is the interesting part. We are going to interact with this name field. So we need to, how we interact with it. Are we going to click on it, or are we going to enter value into it? We are going to enter value into it. If it is a checkbox, we will click on it. But this is a text field, we will be entering value into it. Let us do name dot. You can see bunch of options on it, right? You need to know what method to use if you want to enter value into it. Think a moment, what do you use? We will use send keys. Send keys is the method we will use if you're trying to enter value into a text field. So I will type in dot send keys, and here the parameter you can pass in is a string. So the value I want to enter into the text field is, let us say, John. Control S. So two steps. One is find the reference to that element, and then second step is enter value into it. I can combine these two into one step, but for the purpose of clarity, I'm keeping it separate. Now let us run the script and see if it enters the value or not. And before that, I want to comment out this piece of code, because if you run the code, it happens so fast, you will not be able to see whether it is entering it or not. So I will comment this so that the browser is not getting closed. And once again, save, right click, run as testng. We see the console output here, but I don't see the browser. And the browser is here, and we are having trouble accessing the page, right? Let us troubleshoot it. This is the part I want you to watch over, so that you know how to troubleshoot is an important aspect. Let me close this, and you know what? We never did driver.get to get to that page. That is why we are not seeing the web page. So let me do here, add that line of code. Driver dot get string, copy the URL, and put it in here within the quotes. Since it's a string, Control S, right click, run as testng. Now we can see the browser opened and the value John is entered. Now let us try using some other methods on web element. So I can go ahead and do like name dot click, name dot is enabled, name dot clear. So let's try with clear and entering the values. In some situations where we want to clear the text field and then enter our value, right? Let us see how that works out. Name dot clear. In here I have added few lines of code. Here I'm clearing the name field and re-entering this value so that we can see that when we are running the script. And bunch of system out statements. One is checking for is displayed, is enabled, is selected. So by the name itself we can guess it's a boolean, right? Is displayed. So if you mouse over it, you can find out the return type. This is what I always suggest, what type of return we are getting from this call. You can mouse over and find out. So all three of these are boolean return types. We will print it to the console, and here we will enter the value, clear it, and again enter the value. So we want to try these 4 methods. So I will run the code. We should be able to see clearing and re-entering the value, and also the console statements for the 3 is displayed, is selected. So John cleared and re-entered as John Doe here. Let me minimize this window and we will take a look at the console. And in the console, if I scroll up a little bit, we can see true, true, false. For the first one, is displayed, it is true because the text box is displayed, and is enabled and the text box is enabled. That is why we were able to enter the value into it. And is selected is false because every method that is present in the web element may not apply for every UI element. UI element means HTML element. So is selected does not make sense for a text box. If it is a checkbox, is selected makes sense, right? So in this case, the text box is not selected, and that's why the return type is false. Okay, so with this I will conclude this lesson. We have seen how to use find element by ID and enter value into it, clear value, re-enter, and check couple of options, the properties of the text element. In the next lesson we will see how to find an element by name, and we will add a little bit of complexity. What if there are 2 elements with the same name? We will see that in next lesson. Thank you. Hey guys, welcome back. In this lesson, we will see how to find a resource by name, and also how to handle if multiple resources are written back which are holding the same name. I will be creating separate class for each lesson so that it will be easy for you to refer it back when you pull the code from Bitbucket. Let us start with creating a new class by name element by name.java. Similar to what we did element by ID, I will create a new class element by name. Under the Selenium package, new, other. Since we want testng, filter for testng, and actually it's right there. Double click on it, and I would like to name it like element by name. I will select add before method and add after method and click finish. By default it created add before, add after, and add test methods. So I will copy the code whichever is relevant, like add before and add after, into this from our element by ID class. So in here I copied the code. Basically it handles the part where instantiating the WebDriver and closing the WebDriver. We comment it out because we want to see the last action that was performed on the web page, right? Otherwise the Selenium will close the browser. We will not be able to see what kind of activity happening on the browser. So for now we will keep it as commented. And let us add our new code, which is driver.findElement by name. Instead of 2-line code, this time I will use the send keys on the same statement itself. So I can do dot send keys. Let us pass the value for the name as Mike. A simple line of code. All it does is find by name, whatever the name of that element is, and enter value as Mike. Let us quickly run this and see how it goes on the browser. So the browser, Chrome browser opened and the WebDriver entered the value Mike for this line of code right here. Driver.findElement by name dot send keys Mike is what it produced this output. Now let us take it to the next level. So this time what we will do is we will find elements that is sharing the same name. So this particular text box and this particular text box share the same name, which is your name. And how to handle that kind of situation when you have two elements returning from the same name. If I want to enter value into nickname, if I do it by find element by name, your name, it will always enter into the first one only. That is how the Selenium works. Whenever it encounters the first element matching, then it interacts with that one. But what if I want to enter the value into the second one, which is sharing the same name, which is your name? Then we have to do by using find elements. Instead of element, we have to use find elements that will return multiple elements. Then we have to iterate, that means pass through the elements and find the second one and enter into it. Let us do that. So I will go ahead and do driver.findElements by name. That part remains the same, except we will be using the method findElements. So again, my recommendation, mouse over to find elements and find out what it is returning. So if you look at here, when I mouse over to find elements, it is returning a list of web elements. So it is returning a list. When it is find element, it's only one web element, right? When we are using find elements, then it is returning a list of web elements. Since it's a list of elements, obviously you cannot use send keys, right? It's a list. So a typical list methods will appear when you use your dot operator. So for a list, there will be size, iterator, get, add. All of these methods are from the return type list. Instead of doing anything here, let us capture the list into a variable, and then we can use that variable to interact with the web elements. So on the left hand side, I will capture the list basically, and it's a list of web elements, right? So a list of web element, and you can give a name whatever you want to. So I will give a plural name like names. Control S, and you can import java.util.list. So our interest is to enter value into the second one. If it is the first one, we would have simply used find element. So for the second one, the way we can reach out to it is using the list and accessing the second element in that list. So list index starts at 0, right? So this would be at the position of 1. How we can do this is simply use this list name dot get the index for the second one, which is nickname, would be 1, and you can use simple dot operator and do send keys to send a value for the nickname. Here I will give the name as Mikey as the nickname for Mike. Now let us run this code and see how the value is populated. So we can see here the first one, find element, is entering the value Mike, and the second one where we are using list to access the list of elements sharing the same name and entering the nickname as Mikey. If you go back to the code, we have used the list and used the send keys on the second element. Indexes start at 0. 0 position is the name, and the second position, which is at index value of 1, is nickname. So on the nickname, I have used send keys and assigned the value. So this is a list of web elements, remember? So if we are doing get 1, means it is returning one single web element, which is the second one from the list, and we are doing send keys on that one, and we are sending keys basically on this one. So the index 0 holds reference to this web element, and index 1 is holding value to this web element. You can simply use dot get 0 send keys for the first one. Instead of using this find elements, you can do that too. But the whole point is how to handle elements with the same name and use a list to access whichever element you want to access. With that, I will conclude this lesson. I will check in this code into Bitbucket, and you should be able to access it whenever you want to. Thank you. Hey guys, welcome back. In this lesson, we will discuss about how to find element by XPath, and also how to make use of Chrome developer for finding XPaths. We have to accept the fact that having a unique ID and unique name in a web page is not possible. There will be situations all the time where you cannot find a unique ID for an element. Either the ID keep on changing, which you cannot use it in the script, right? If the ID is changing, the script will not work because it's looking for certain ID and that ID is no longer present. And same applies to the name also. You cannot expect the name of an element to be consistent all the time, especially with not recent in the sense 1 or 2 years, but last couple of years, the UI has become more JavaScript library based front ends, like using AngularJS, React.js. These libraries create these UI elements, and a typical developer has no control over what will be the name, what will be the ID, of the elements. That is when XPath will come into the picture. So XPath is so powerful, we have to be very good in XPath if you are a test automation developer. So XPath is defined as XML path. It's the syntax we use on a web page using XML path expression, so that to find an element on a web page using HTML DOM structure. So the HTML structure typically consists of starting with HTML tag at the top and title, body, and all of the elements go into the body, closing tag for body and closing tag for the HTML. You can refer back to the HTML lesson we have covered. So, but XPath usually uses this different child parent element structure to access whatever element you want to find on the web page. Let us take a look at how to handle XPath using Selenium. We can start with creating a new class. Under the Selenium package, I'm creating a new class, testng class, and I will type in testng, select it and click next, and I will name it element by XPath. And select at before and at after methods. So in here, our typical routine, I will copy at before and at after lines of code, and we will focus on at test, how to use XPath to find an element. Let us rename the test method. Instead of simply one letter, let us make it test by XPath. Here we can put our driver.get to access the web page. Now let us take a look at our web page and select an item to access by XPath. So on this page, we can access one of these elements by XPath. I will select submit button, and let us see what action it is taking when I click on the submit button. When I click on the submit button, I have set it up to go to the home page. And I clicked on the submit button and it went to the home page of this testautomation.co. So let us go back here and find out the XPath for the submit button. Right click, inspect, we get this Chrome developer tool. So for XPaths, I strongly rely on Chrome developer tool. It's an excellent tool to find out XPath. Not only that, you can also verify your XPath is correct or not. That is very handy. Just getting an XPath is not just enough. You want to test it even before using in your script so that it is more reliable. Here in the Chrome toolbar, when I click on this little icon at the top and click on submit button, it selects and locks it here. Now I can access by name, but that is not the point. We want to access it by XPath this time. Assume that this name is changing all the time. Then you cannot reliably use the name. In such situations, we can use XPath. Right click here in the Chrome toolbar and you can do copy XPath. That copies the XPath to the clipboard. And let us open a notepad and paste it. This is the XPath by default Chrome toolbar gave us. And go back to the Chrome toolbar here and do Control F. That means searching this DOM by using XPath is possible. You'll get this little text box here. You can paste whatever the XPath you got, and you can see that element is getting highlighted. So it is representing, this XPath is representing this element, which is being highlighted. That is nothing but a submit button. As it is, you can use this XPath into your Selenium find element. If I take this code and copy this code and paste it into find element, it will simply click on the submit button. But we are not going to stop there. We are going to have more control on the XPath. I will show it to you right after we run this Selenium script one time by using the default XPath that was given by Chrome toolbar. So in here I will do driver.findElement by XPath and simply paste this XPath. And now I'm going to run this Selenium script for XPath. And we see the browser fired up. And nothing happened. Again, one more chance to troubleshoot what happened behind the scenes. I'm intentionally including these errors so that you can learn from them, so that, you know, if happy path, if everything works fine, then the chances of you learning is less. Let us see what's happening here. The test ran okay. This is a simple problem. I found the element, but I never did any action on it, right? It's as simple as that. So I will do dot click on it. This is the action we want to perform. Save the code and rerun. The page opened and submit clicked and it went into the home page. So the XPath worked as it is, as we got from the Chrome toolbar. Now with this XPath, I'm not very comfortable with it because I want it to be more precise and I should have control over it. When I say control, if I build the XPath by myself, I understand it from ground up. This I can simply understand it, but I want it to be much simpler than this one. I will show you what I mean. Let's go back into the Chrome toolbar. So whenever we make change here, that reflects in this DOM and also on the web page. So I remove the T and typing back the T, then it highlights in yellow here the DOM element and also the element submit button on the left pane. We need to pay attention to both of these, especially which element is getting highlighted. This particular default XPath is good, but I want to build my own. So how I can do that is basically 2 forward slashes represents relative XPath. That means it won't start from the root like HTML, title, body. It won't start from the root of the document. It will start from whenever it encounters a element which I'm going to give right after this 2 forward slashes. So in our case, the submit button is input type. So the tag is input. Let me show it to you one more time. Right click, inspect. Here the tag is input, right? So I will type in input, and then I need to filter the inputs. There are 12 inputs on this page, so I need to filter it. The way I can filter it is, this is of type submit. So I know that fact because the submit button is of type submit. Type submit is the attribute on the submit button. So type equal to submit. You see that this is an attribute. Name is an attribute. Value is an attribute on the submit button. So inputs, there are 12 of them on this page. Then that is not a good thing. It's not unique enough to click on the submit button, right? So I need to filter a little bit more. For that, what I will be doing is I will be filtering based upon the attribute. For that, I will use the square bracket here and use @ symbol and type, which is an attribute. What type is it? It is a type submit. So once I put in type equal to submit, we can see it got highlighted here, and on the left pane on the web page also the submit button got highlighted. So a simple XPath I built uniquely identifies the submit button on the page. If you can see here, the results, there is only one element that is matching this XPath, which is a lot better than, let us copy this, lot better than the default one provided by Chrome toolbar. This is something you can build on your own so that we have control on it, like understanding where the element is, what type of attributes you want to use, so that you can better understand it by yourself. Let us take this XPath and run the code one more time, replacing the existing one. I will comment this line for now. And right click, run as test-ng. The browser fired up web elements page and clicked on submit button, and it went into the home page. So, and here the tests were passed. Simply we used input type attribute as submit and able to run the test. So this is the way you can either use the default, or I highly recommend building your own XPath by simply using the text window, by going through what type of tag you're going to use, the type of the tag, and any attributes that are unique to that element. Use them as a filter. XPath is so critical for test automation development. We will be seeing more XPath examples in upcoming lessons. One of them will be, what if one attribute is not sufficient to make the XPath unique enough? We can use multiple attributes using AND operator within the XPath. So we'll be seeing some more examples as we go forward. With this, I conclude this lesson. You may now move on. Thank you. Hey guys, welcome back. In this lesson, we will see Selenium weights. What are weights? Why we need them? And what are the various types of weights? Let us start with the definition for weights. So weights are to hold automated tasks like code execution for a certain amount of time before continuing with the next step. This means that we can tell Selenium that we would like to wait for a certain amount of time before throwing an exception that it cannot find an element on the page. One of the biggest issues we face when automating web pages is timing issues. Keeping the test script and actual web pages in sync is critical to avoid synchronization issues. Some pages load fast and some don't. And also some UI elements takes longer to load, which has a term called lazy loading. The advanced UIs we are using, such as AngularJS, React.js, for better user experience, are designed for lazy loading. When a web page is loaded by the browser, the elements which we want to interact with may load at different intervals. Let us take a look at the example on our Web Elements page. On this page, we can notice explicit wait button slowly appears after some time of page load. If Selenium WebDriver starts to click on the page as soon as the page loads, it will fail and we will get element not found or element not visible exception. This problem can be solved by using waits. There are three types of waits available in Selenium. They are implicit wait, explicit wait, and fluent wait. Let us see what an implicit wait is. An implicit wait is used at a WebDriver level. If you create an implicit wait, it is active throughout the life of the WebDriver. The implicit wait will tell the WebDriver to wait for a certain amount of time before it throws an element not found exception. So it is basically we are instructing the WebDriver to wait for, let us say, 10 seconds before giving up and complaining that element is not found on the web page. The syntax will be driver.manage.timeouts.implicit wait, and whatever the timeout amount you want to use, like 10 or 12 seconds, comma, the units, which is seconds in our case. So in this example, the element, if the element is not located within 10 seconds, it will throw an exception. But for 10 seconds, it will try to find the element on the page by regularly polling if the element is available. Now, explicit wait. An explicit wait is code you define to wait for certain condition to occur before proceeding further in the code. Explicit wait is most powerful wait. It is not only going to wait for certain type, but also verifies certain expected condition is satisfied. What does it mean by expected condition? There are some common conditions that are frequently encountered when automating web browsers, such as a button is clickable. When you are filling certain forms online, you see the submit button is disabled until you finish all of the mandatory input, right? So the explicit wait will check for the condition, such as if the element is clickable or not, before clicking on it. So if the button is not clickable and if you try to click on it, you will get an exception. So before running into that exception, you want to check whether the button is clickable or not. The explicit wait gives this extra level of validation before clicking on it. And again, it has this feature of waiting for whatever time you prefer to wait on certain element. It's a combination of implicit wait functionality, like waiting for 10 or 12 seconds, and on top of that, you're looking for expected condition to be satisfied, such as the element is clickable or not. So there are many kinds of expected conditions we can use. The good place to find all of them is in Selenium API documentation. Some of the most frequently used ones are element to be clickable, text to be present, visibility of the element. These are the few very popular ones. Here is the syntax for explicit wait. It is a two-step process. In the first one, you will declare the wait, and in the second one, you will check for expected condition. So here we have declared a WebDriver wait with a 10 seconds elapsed time, and we have the condition which is making sure the element is clickable. In this case, XP button is clickable or not. Now let us take a look at Fluent Wait, the third one in 3 waits in Selenium. The Fluent Wait is enhanced version of explicit wait. It is the latest addition to the waits in Selenium. The enhancement it provides is how often to check the expected condition. In case of explicit wait, this is handled by explicit wait internally. In Fluent Wait, you provide the time how often you want to check the expected condition. This is also called polling time. So general recommendation is don't combine explicit and implicit waits. Explicit waits are highly recommended because you wait while we are verifying for expected condition. With this, I conclude this lesson. In the next one, we will see how to code for implicit waits. Thank you. Hey guys, welcome back. In this lesson, we will see how to implement implicit wait in our script. Let us have a quick refresh on definition. An implicit wait is to tell WebDriver to poll the DOM for a certain amount of time when trying to find an element if they are not available immediately. Let us say we are doing a Google search and the Google search button is not available immediately. Assuming the page is loading slowly, then we are telling the WebDriver to wait for a certain amount of time before it throws an exception. Let us start with creating a new TestNG class for implicit wait. Under the Selenium package, I will create a new TestNG class and name it as implicit TestNG. So here I will fill in the method, before method and after method, and then we will go from there. For now, we will keep this driver.quit commented so that the browser won't close when we run the test. And I will rename the test method from F to something reasonable. Let us say test implicit. In here, we will add code to access a link on Web Elements page. Let us take a look at Web Elements page for the link. So on this page, we will try to access the dashboard link, which will take us to the sign-in page. So the dashboard link, let us find out the ID on this link. So it's an ahref link with an ID, link to courses. So in our find element, we will use link to courses, and we'll add the click command on the same line. Let us quickly run this test. This is supposed to be straightforward, just clicking on the courses link. We can see the browser fired up and dashboard link clicked, and we went into this sign in page. This is fine so far, but what we want to see is script failing because it's unable to reach an element. For that, we need to tweak a little bit. We have to make some assumptions. We will assume we are looking for a link to courses 1. Okay, I know it's not existing, but let us assume that we are looking for a real link by name, link to courses 1. So if we run the code, we will get no such element found exception. That is guaranteed. But what we want to demonstrate is how much time it took to throw the exception before using implicit wait and after using the implicit wait. First, let us run without using implicit wait. Right click, run as testng. Browser fired up, and we can see the exception immediately. So let's scroll up and see what it is exactly. And we can see no such element exception, unable to locate link to courses 1. Expected, but it happened very immediately, right? Now let us add implicit wait and see how it responds. Let us add implicit wait in add before method. You can write it here right next to this one, or you can do it before the test method. I would prefer in as part of before method because implicit wait is effective throughout the life of the driver. So we will put it here, and the syntax is driver dot manage dot timeouts dot implicitly wait. The first argument is how many seconds you want to wait. I would say 10 seconds before throwing an exception, and the unit of time we want to use is seconds. So time unit dot seconds. We'll save it. Now let us run the script and pay attention to how long it took to throw no such element exception this time. Right click, run as testng. Browser fired up. I will move the browser to the side so that we can see the console. 1, 2, 3, 4, 5, 6. It took about 10 seconds to throw the exception this time. It did not throw it immediately. So Selenium is trying to find again and again by polling if there is an element by name linked to courses 1 is available on the DOM. It did not find after till 10 seconds, and then it threw an exception. So implicit waits are not highly recommended because it doesn't give you a full control. It will just wait for 10 seconds and throw an exception. Whereas the power of waits lies in using explicit waits, which we will see in the next lesson. With this, I will conclude this lesson and try to avoid using combination of implicit waits and explicit waits. Thank you. Hey guys, welcome back. In this lesson, we will discuss about explicit wait. In the previous lesson, we have seen implicit wait, which will wait for n number of seconds and move on. Either it throws an exception, or if it finds the element in n number of seconds, it will move on to the next line of code. On the other hand, explicit wait not only wait for n number of seconds, but also verifies the required element you're looking for is in expected state. For example, you are waiting on a button to be enabled. before you click on it. There is no point in clicking on the button if it is not enabled. So explicit wait will check whether the button is enabled or not on top of waiting for the button to appear. Like always, let us look at the definition for explicit wait. So expected wait is used to tell the WebDriver to wait for certain conditions, which we call now onwards expected conditions. These expected conditions are met or simply time exceeded the wait time we have provided before throwing an exception, such as element not visible or element not found exceptions. First, we will see a problem, and then we will solve the problem using explicit wait. Sounds good? Let us go into Web Elements page on testautomation.co. This page has a special button that I have created to use with explicit wait demonstration. In here, pay attention to the space next to delayed button. We will see a button appears after few seconds of page load. This is the delayed button label I'm talking about. Watch out this space. We can see explicit wait button appeared after few seconds of the page load. Now when I click on this explicit button, it will take us to the Selenium course page. To start with, let us create our usual Selenium script to interact with this button, not using explicit wait, general find element by ID, whatever the button ID is, and see what kind of exception we will get, and then we will see the solution. I will be creating explicit testng.java file, which will be based out of implicit testng.java, and additionally I will be adding the code to find the element, which is the red button we saw earlier that has a delayed start. Here we have created a simple explicit testng file. It has a before method, at after method, and at test method. And in this method, we're trying to find an element by ID expli button, and then we want to click on it. So what we are trying to do is we want to find this element here, which is an expli button, and try to click on that button. This particular script does not have any waits as of now. So let us run the script and see what kind of problem we will run into, and then fix it with explicit wait. I'm running as testng. We can see the browser is fired up and the delayed button did not appear yet. Already we can see a failure here. So let me scroll up and see what's going on. And In this particular test, we are getting element not visible exception, element not visible. And this is happening on the line number 28. So here driver.findElement is trying to reach out to XP button by ID and trying to click on it, but that button did not appear on the screen yet. When you attempt to click on something that's not there yet, we will get exception. That is what we got here, which is element not visible exception. Now let us try to fix it using explicit wait. Explicit wait will have two steps involved. First, we need to create a WebDriver wait, which we will use to give a default wait time on waiting. And then the second step is writing down the expected condition. What do you want in that expected condition? In our case, we want to click on the button only after it is visible. So I will use expected condition visibility of element located. That means I'm suggesting WebDriver to wait until that button is visible. So in the two-step process, we will create first WebDriver wait object, and then in the second step, we will write down our expected condition. Let us start with WebDriver wait. Here we have multiple options to select with, but we need to be focusing on what we want. We want the element to be visible before clicking on it. So I will use visibility of element located. So in these two lines of code, the first one, the line number 29, is basically we are declaring a WebDriver wait with a wait time of 15 seconds, and then we are suggesting expected condition, which is visibility of element located for this element. Now we don't want to click before the wait, right? So let us move this line of code after the wait and see what happens once we run it. It is supposed to wait until the red button appears and then click on it, and we should go into the Selenium course web page. Now I'm running this, right click, run as test-ng. The browser fired up and the element did not appear yet. If you look at the delayed button area, now this time successfully we clicked on the button and went into the Selenium course page. And if we look at the log console, we don't see any failures. So this WebDriver wait really worked, so that it is waiting till the button is visible and then only clicking on that element. We have solved the problem by using a wait which has expected condition within it. So when we are choosing expected conditions, you need to be aware of what kind of state you are expecting on that element. In some cases it's visibility, and some cases the element to be clickable. In certain forms, when you are filling up the form, if you don't fill the mandatory elements on that form, the submit button will be disabled. So in that case, you may want to check for the element is clickable. So the biggest advantage of using explicit wait is it does wait, and also it takes care of verifying the expected conditions. This is the most used wait in Selenium when compared to implicit and fluent. Let us run one more time. And the last time we have missed clicking on that button. It is out of the screen area. There we go. So as soon as the button appeared, explicit wait passed to the next line of code, which is clicking on that explicit button. Let us say if we give the explicit wait little less time, right? The delayed start button is starting like after 6 seconds. But let us give the WebDriver wait of only 4 seconds and see what happens. Right click, run as test-ng. We gave only 4 seconds, the button did not appear. Let us go back into the script and we can see the exception happened. The timeout exception happened because we passed out the elapsed time of 4 seconds and the button did not appear. We got this timeout exception. So here is one important interview question. So what is the difference between the timeout exception and element not visible exception? Element not visible exception is thrown by the WebDriver find element, whereas timeout exception is thrown by the WebDriver wait object. So if the time elapsed before we find the element, then we will get timeout exception. If you cannot simply find the element, then you will get element not found exception or element not visible exceptions. Let us switch back to 10 seconds so that we can end this lesson on a happy note, right? We want successful scripts. So now it clicked on that button and we are able to go onto the Selenium test automation page. In this lesson, we have seen a problem of synchronization where the element is not available to interact with, and we saw an exception, element not visible. And then we solved the problem by using explicit wait and using it expected condition by checking visibility of the element. Hope you had a clear understanding. If not, replay and watch it again, because you will be using explicit wait most often in your regular coding. In the next lesson, we will see fluent wait, an extension for explicit wait. Thank you. Hey guys, welcome back. In this lesson, we will discuss about assertions. Why we need assertions, what is a hard assertion, and what is a soft assertion. Assertions are a way to check whether you are getting expected values back, whether it is from the web page or within the test script itself. What we are writing are test automation scripts. So there is no human looking at them all the time, right? They're supposed to run on their own on regular basis. That is the purpose of automation tests. We are creating tests, but how to verify the tests are getting expected results or passing the checkpoints that you usually check manually. For example, when you manually test an application, let us say login into the course. You know, when dashboard appears, you are successfully logged in. For automation, since it cannot visually confirm the dashboard page, the way we confirm is by using assertions. Let us take a look at definition and we will go from there. Assertions provide a means for users to validate any kind of test. The assertion results are based on comparison of actual and expected results. A test is considered passed only when assertions show no exceptions. Thus, the usage of assertions play a vital role in identifying the flaws in the application being tested. So if you use assert in your test, then the test will be aborted if the assert fails. Next test case will start executing in case you're running a test suite. That means multiple test cases. There are two types of assertions. One is hard assertion and the another one is soft assertion. Hard assertion is a default assert mechanism in TestNG. We use it when a test has to stop immediately after the assertion fails. So we use hard assertions in case where there is no point in moving forward if the test or the assertion fails at that point. Let us say you're logged into an application and you're not able to get into the dashboard. Then there is no point in moving forward. You cannot do any kind of actions in the dashboard like going into a course, clicking on a lesson. You cannot do any kind of operation. There is no point in moving forward. In that case, you will use hard assertion. And soft assertion is a custom assert mechanism supported by TestNG. We use it when a test has to continue execution even after an assertion fails. So this is the case where, let us say, in the previous example, the login was successful, but a couple of links were not working. In that case, you don't want the test to fail, but simply report the links were failing and still continue the test, right? In that case, you will be using soft assertion. Let us discuss commonly used assertions. So assert equals. Assert equals works by comparing expected value with the actual value. The assertion passes if they both are equal. Assert not equals is opposite of assert equals. It expects expected value and actual value are not the same. If they are same, it gives an assertion exception. In some cases, you need to check both of the values are not the same. In that case, you will use assert not equals. Assert true passes the test step only when the Boolean value returned is true. So it accepts a Boolean value. If the value is true, assert true passes. If it is not true, then you will get an assertion error. Similarly, assert fail passes the step only when the Boolean value returned is false. Assert null verifies if the object under test is null and passes if it is null. Assert not null, on the other hand, verifies the object under test is not null and passes only if it is not null. Otherwise, throws an assertion exception. So typically, you will be comparing string values or verifying Boolean or verifying null values. Once again, string, Boolean, and null values. These are the three data types we will be checking mostly in assertions. It depends upon the situation which assertion you will be using. If it is a page title verification, string will do. If it is an object, then you will be checking for null, not null. And if it is a condition, then you will be using a Boolean. We will see the examples when we code. With this, I will conclude this lesson. In the next lesson, we will see hard and soft assertions in action. Thank you. Hello guys, welcome back. In this lesson, we will discuss about how to write assertions, specifically hard assertion. Once you learn hard assertion, soft assertion is very similar, except it has few additional advantages. Let us take a look at what is a hard assertion. So a hard assertion is a default assert mechanism built into TestNG's org.testng.assert package. We use hard assertion when we want the test to stop immediately after the assertion fails. It's like hard stop. When will be hard assertions used? As a tester, you will be looking for certain condition to be met before moving further in testing. There is no point in moving forward if certain condition is not met. For example, if the login screen did not work, there is not much you can do inside the application, like navigating through the dashboard. So, a hard assertion, you can use it for a login screen. If you are not able to see the dashboard page, you will fail the test. In simple words, I would say assertions are like a substitute for a tester's eyes. So you are not present when the tests are running, but you want somebody to look after them. In that case, you will use assertions so that you will check for conditions met or not. If the condition is met, you will move to the next step. If the condition is not met, then you will stop the test. Let us start with creating a hard assertion example. We will use our usual TestNG class and we will try to search on Google and assert the title of the page. Here in Eclipse, I'm creating a new TestNG class by name hard assertion example. We'll select add before method and add after method. Finish. I will copy the code from my testng class.java, which is pretty much doing a Google search by using Chrome browser. We're getting the Google homepage and getting the title and finding the search field, entering search term testautomation.co and clicking on the button. So far, there is no new code except I changed the name of this method to test hard assertion. So here, now, which is a good point or place in this code to use hard assertion. Let us say once we get the URL, once we access the website google.com, I want to assert on the title of the page. So here we're getting get title of the Google homepage. I want to make sure the title says Google. If it doesn't, I want to fail the test. So let us look at how to implement hard assertion to check the title of the page. Before that, let me run this code and see everything working properly. Right click, run as testng. And we see the console and I don't see any browser firing up. Let's see what's going on here. Illegal state exception. The path to the driver executable must be set. So we're missing to set the path That's what the complaint is. Here we have set the path as WebDriver IE. See, this is a copy and paste error. Previously we were using Chrome. For some demo purpose I changed it to IE, so it's not able to find the IE driver and we got an illegal state exception. So this should be the Chrome driver. Let me fix that little quick. And run it again. You can see the browser fired up and it entered the search term, and we got the search results page, and driver.quit closed the browser. For a moment I will comment this code so that the browser won't close away. And our goal is to assert on the title of the page. So the Google homepage title is Google. So what we can do for the assertion part is, instead of printing it out to the screen, I will send it into a variable. So here I will declare a string and get the title of the browser. So the title of the web page, which is google.com, will be passed into this variable, and I will declare one more string, which is the expected value. Assertions are, we are going to use assert equals. There are different types of asserts like we discussed in our previous lesson. One of them is assert equals. Assert equals will compare one object to another object and make sure they are the same. So for the comparison purposes, this is the actual value that we are getting from the title of the page, and the expected value is what as a tester I am expecting, right? For the expected value, I will declare one more string, let us say by name expected title of Google homepage. So my expectation is the title should be Google. I don't want the current URL, so I will remove that line of code. And in here, we will add our assertions. To add an assertion, what you need is assert dot, it will provide the solutions. We will use assert equals because we want to compare two objects. In our case, it's two strings we want to compare. So look for the data type that matches to string comparison. So this is where we can use two string comparisons. If you look at the parameters, string actual, string expected. And in here, actual is whatever the driver is returning back to us. So this is the actual, and expected is what is our expectation, which would be this. So this assert equals, look out for a true condition. Like true condition means whether this and this value are the same. If it is true, there won't be any assertion error. If they are not equal, then we will get an assertion error. In this case, you can guess we won't get an assertion error. Let us run this code, and later we will change the expected value and see the assertion error. Right click, run as testng. Browser fired up, search term, search, and we commented out the quit part, right? So the browser is still open for us. More importantly, in console you don't see any errors. Okay, now let us close this manually and let us change the expected value. Let us say our expectation is the title should say Google Home. Okay, I will save this code, right click, run as testng. Now it compares the actual value to Google Home, but it is Google here on the title. It already failed. It did not go to the next step at all, entering testautomation.co as the search term. We already got the test failure. Let us scroll up and see. Here we can clearly see java.lang.assertion error, expected Google Home but found Google. So it's clearly giving us what is the expected value and what it found. And since it is a hard assertion, the test stopped immediately when it failed. It did not even go to the next step. Let us fix this back to Google. Similar to assert equals, we can use assert not null, assert true, assert false. There are many different assertions you can use. Let us see the example of assert not null. So we can use that assertion to check for the particular object is not null. You don't want to use null values. So before using that value, whatever the value the variable is having, you want to check for not null. Let us create a scenario for that. So this search term, I will make it as a variable. So I will declare it as a string search term and initially assign it to null value. And in the next line, I will assign value to the search term. Since it's a string, it has to go in quotes. And here we will replace this hard-coded value with a variable which is search term. Right now, if I run this one, it should work as before. All we did is we took away the search term hard-coded value from here and moved it into a variable. Now, here I want to assert before the search to make sure the search term is not null. So what I can do is use assert.assertNotNull, and the object I want to check for not null is search term. Right now, as it is, since the value is assigned to the search term, we should not see any assertion error. Let me save and run as test.ng. We can see the search term entered and search performed, and we don't see any failures. Now let us assume that we forgot or there is no value assigned to the search term. So I will comment out the line number 22, which is where we are assigning value to the search term. And now let me run this. Technically, search term is having null value and we are checking for assert not null. We are supposed to get assertion error because it's a null value, and we are looking for not null condition. Let me right click, run as test.ng. And it did not enter the value, and we can see a failure. Let us scroll up and see the error, which is assertion error, expected object to not be null. So it is expecting an object which is a not null, but it got a null object. So assertion caught this error and throw an exception. For critical failures, hard assertions are a good way. When I say critical failures, if certain feature is not working as expected or the values are not correct, then there is no point in moving forward. In such cases, hard assertion is what you need to use. But there will be certain conditions where you don't have to fail the test but continue the test. You can report the failures at the end of the test. In those cases, we will use soft assertion, which we will see in the next class. For now, remember, hard assertion is used for failing the test immediately if the condition fails. With that, I will conclude this lesson. You may now move on to the next one. Thank you.